So in this question we use the method of substitution. We let u equal to the bracketed term with the highest power, which in this case is the denominator, 2x cubed plus 3x squared plus 5. So now get the u dx, so differentiate this expression and we get 6x squared plus 6x. Cross multiply gives the u equals 6x squared plus 6x dx. Take out the 6 and we get the u equals 6 times x squared plus x dx. Now the x squared plus x dx is what we want on the top, but here we have 6 times x squared plus x dx. So divide both sides by 6 and we get x squared plus x dx is du over 6, and this is the top term. So substitute du over 6 for the top term and we get du over 6 divided by the square root of u, which is the bottom term. So we can take out the 1 over 6 and we can write the square root of u as u to the power of a half, and 1 over the square root of u is u to the power of minus a half. So now integrate u to the power of minus a half. So we add 1 onto the power, so adding 1 onto minus a half gives us a half, and divide by the new power, we divide by a half. Now when we divide by a fraction, that's the same as multiplying by the inverse of the fraction. So dividing by a half is the same as multiplying by 2 over 1. 2 into 6 goes 3. So we're left with 1 over 3 times the square root of u. So substitute the value of u back in for u, and now substitute the limits, and we get 1 over 3 times 9.54, which works out to be 3.18. So in part B, we used the method of partial fractions to solve the integral. So what we do is we let the integral equals a over x minus 1 plus b over x plus 2 plus c over x minus 3, and we need to try and work out the values of a, b and c. So if we use the common denominator, we can add the three terms, and this will give us a times x plus 2 times x minus 3 plus b times x minus 1 times x minus 3 plus c times x minus 1 times x plus 2. And if we equate the numerators on both sides of the equal sign, we get the top line here, 6x squared plus 7x minus 25, must equal the top line on the right hand side, which is given as follows. So what we need to do is choose values of x so that we can work out a, b and c. So first of all, we see that if we let x equal to 1, the b and the c terms will become 0, and this will give us the left hand side, which is minus 12 equals minus 6a, which gives us a equals 2. So now to get an expression for b, we let x equal to minus 2, which will make the a term and the c term 0, and this will give us 6 times minus 2 squared plus 7 times minus 2 minus 25 equals the expression here shown. So this means minus 15 equals 15b, which means b is equal to minus 1. So we now have a and b, and we have to find c. So to find c, what we do is we let x equal to 3. Again, this will make the a and b terms 0. So this gives us 6 times 3 squared plus 7 times 3 minus 25 equals c times 10, which means that c is equal to 5. So we now have a, b and c. So the expression, the original integral, now becomes 2 over x minus 1 minus 1 over x plus 2 plus 5 over x minus 3. Now we know that if we integrate 1 over x, we get log x. So if we integrate 1 over x minus 2, x minus 1, we get 2 times the log of x minus 1. And 1 over x plus 2, when we integrate it, we get log of x plus 2. And integrate 1 over x minus 3, we get log of x minus 3. Now we could use the rules of logarithms to write the log of a to the power of b as b times the log of a. So really we have b times the log of a here, we have 2 times the log of x minus 1. So that's going to become log of x minus 1 squared. And similarly, 5 times the log of x minus 3 will become log of x minus 3 to the power of 5. And the log of a times b is the log of a plus b, or the log of a plus b is the log of a times b, and the log of a minus b is the log of a plus or a over b. So if we use these logs, the rules of logs, we could write the final expression as log of x minus 1 squared times x minus 3 to the power of 5 over the log, or over x plus 2. So the last thing we need to do now is put in the limits. So we need to substitute 5 and 4 into either of the two expressions. So let's take the expression on the left hand side. So if we substitute 5, we get the following expressions. And if we do the maths on this, we find that the final answer is 3.88. In part C, we use the method of integration by parts, and we use this method when we have two functions multiplied together. So here we have to decide what's going to be u and what's going to be dv. So in this case, let u equal to 2x and let dv equal to the remainder, which is e to the 3x times dx. So differentiate u, we get du dx equals 2. This means that du equals 2 times dx. And over here we have dv equals e to the 3x dx. So if we integrate dv, we get v, and integrate e to the power of 3x, we get 1 over 3 e to the 3x. So we have u, we have dv, we have v. So we substitute all of these values into the formula, which gives us uv, which is 2 times x times v, which is 1 over 3 e to the 3x, times minus the integral of v, which is again 1 over 3 e to the 3x, times du, and du is 2 times dx. So if we tidy this up a little bit, we get 2 over 3 x to the power of x times e to the power of 3x minus 2 over 3 e to the 3x dx. So integrate e to the power of 3x, we get 1 over 3 e to the power of 3x. And again, if we simplify this, we get 2 over 3 x times e to the 3x minus 2 over 9 e to the power of 3x. So once again, we need to put in the limits. So if we substitute 3 and 2 for x, and we get the following expression. And if we tidy this up, we get 5,402.